To transfer the data from one node to another node, I must require one-to-one connection or point-to-point connection. And there are three types of switching. One is circuit switching, packet switching, and message switching. Static in the sense what? A fixed route. Each time I want to follow same route. But what about dynamic? Each time I can able to change the route. Hello friends, a warm welcome to my new session on the physical layer. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last session, I have discussed unguided media. So what is unguided media? That is unbounded media or wireless media, and how I'm going to transfer the data through the free space or through the air. And I also discussed the three types of unguided media, that is radio wave, microwave, and infrared. But in my today's session, I'm going to deal with switching. In that, I'm going to deal with the type of switching, that is message switching and multiplexing. These are the three topics I'm going to deal in my today's session. Now, let me to discuss what is switching. So, dear student, think that I'm going to send a data to receiver. Think that A is the sender and B is the receiver. In middle, I'm going to have the intermediate node D and C. Okay. Now, to send the data from A to B, I can directly send, that is A to B, or I can able to send the data to D and from D to B, and another way A to C, C to B. So how many paths I have here? Total 3 paths, and I want to select the best path, and this is known as switching. So what is switching here? Switch. In a large network, there can be multiple paths from sender to receiver. Think that this is my large network and I have multiple devices, and when I want to transfer the data from sender to receiver, I can have multiple paths. And if I consider this example, see, A want to send data to B, but how many paths I have? I have 3 possible paths, that is A to D and from D to B, or A to B directly, and another one is A to C, from C to B. So here the switching is the technique. It's a technique which is going to decide the best route. It's going to decide the best route for data transmission. See, I have 3 possible routes, and in that I want to select the best route, and that is known as switching. So here switching technique is used to connect the system for making one-to-one communication. So dear student, in switching, I'm going to select the best path. Why I'm going to select the best path? To transfer the data. To transfer the data from one node to another node, I must require one-to-one connection or point-to-point connection. So switching communication networks are those in which data are transferred from source to destination, is routed between various intermediate nodes. So what is intermediate node? See here, if I consider this example, D and C are the intermediate node, and if I consider A to B, it is a point-to-point connection. It's a point-to-point connection. In the sense what? There is a dedicated link between A to B. But if I consider A to D and B, or A to C and B, here C and D are the intermediate node. In the sense what? A want to send the data to D. Now D is responsible for forwarding that data to B. And if I consider another scenario, A is going to send the data to C and C is responsible for forwarding the data to B. So here D and C are the intermediate node. Now, if I consider switching, switching is the technique by which nodes control or switch the data. So here node is nothing but the device which is responsible for switching the data. Switching the data in the sense what? Transferring the data. And there are three types of switching. One is circuit switching, packet switching and message switching. So circuit switching, where we are going to come across circuit switching, that is our telephone line. And if I consider packet switching, as the name itself indicates that the data are transferred in the form of packet. So what is packet here? Think that I have the data and the size of the data is very large. So what I'm going to do, I'm going to break this data into three different packets. So it is packet 1, packet 2 and packet 3. And I'm going to send the packet one after another. So that is my packet switching. Then what about message switching? So dear student, according to our syllabus, we are going to focus only about this topic, that is message switching. So in message switching, I'm not going to break the data. Whatever the data, whatever the message I'm going to have, I'm going to send that message to the recipient. But here I'm going to use store and forward concept. Message switching is a switching technique. The entire message is transferred from sender to receiver. So what I'm going to do, I'm going to send entire data together and I'm going to use the concept called stored and forwarded. Let me to draw the diagram here. So I have sender A, receiver B, middle I have the D, mediator, and C I have the mediator. Okay, in switching, that is message switching, think that I have the data D1, I have the data or message D1, I'm going to send this data D1 to D. Now D is nothing but the intermediate node. It's responsible for storing the data in his memory. Okay, then forward that data to B. Okay, now intermediate node must have the storage capacity. Why? Because each intermediate node is responsible for storing the message and forward the message. In message switching technique, there is no establishment of dedicated line. So there is no direct connection. There is no end-to-end connection here. Okay, we are going to have the intermediate node, that's nothing but the mediator. So there is no dedicated link. The destination address is appended to the message. For example, think that D1 is my message. Along with this message, I am going to append or add the destination address. Message switching provides a dynamic route. It's not static. Static in the sense what? A fixed route. Each time I want to follow same route. But what about dynamic? Each time I can able to change the route. And if I consider this example, I have two routes. One time I can consider first route. In the next time I can able to consider second route. So each time I'm going to change the route. So it is known as dynamic routing. Now dear student, see here, this is the example used to illustrate message switching. So all the data, whatever the data I have, that is treated as message. See, I have the message 1 and message 2. Now, A want to send the data to B. And I have the mediator. So, these are the mediator or these are the intermediate node. Now, to send message 1, A is going to consider the first route. So, A is going to send the data to S1. Now, S1 is responsible for storing the data and forward that data or message to D. Now, D is going to receive the message 1 and store that message in their memory. Now, forward that message to S6. Now, S6 is going to receive the message 1, store message 1 and forward that message 1 to B. And in the next time, I have the message 2. In the next time, I'm going to consider another route. So, what I will do, I'm going to use S1. So, here S1 is going to receive the message 2, store the message, forward that to S2. Now, S2 is going to receive message 2, store the message and forward that message to S3. Now, S3 is going to forward that message to S4, store that message in S4 and forward that message to S6. X6 is an intermediate node responsible for storing the message 2 and forward that message to B. So, here message switching are the program in such a way that they can provide most sufficient route. So, here we are going to focus only the best route. Each and every node is responsible for storing the entire message, then forward the message. Now, to store the message, I must require sufficient memory. And this technique is known as store and forward network. So, each message is stored in the mediator or intermediate node, then forward that message. For that reason, it is called store and forward. Then what is the advantage here? Data channels are shared among the communicating device. So, whatever the data channel I have, that is shared between all the devices. So, it improves the efficiency. Traffic congestion can be reduced. Each time, instead of following same route, I can able to take some other route because it uses dynamic routing. So, each time instead of taking same route, I can able to consider alternative route. Okay, for that reason, it reduces traffic. What is traffic here? That is network traffic or network congestion. Message priority can be used to manage the network. For each message, I can able to provide the priority. By using message priority, I can able to manage network. The size of the message which is sent over the network can be varied. Each time, I don't want to consider same size of message. By using stored and forward network or by using message switching, I can able to transfer variable length of the message. Then what is the disadvantage? See here, each node is responsible for storing the message and forward. So, it is insufficient storage. In the sense what? Each mediator device must have the storage capacity. If they have insufficient storage, then it leads problem to message switching. The long delay can be occur. There is a long delay because whatever the message I am going to transfer, that must be stored in the mediator node, then forward. To storing the message and forwarding, it takes time. So, there is a long delay. So, dear student, what are the two disadvantages? The system must have sufficient memory. Another one, long delay. So, these are the two disadvantages. Then I'm going to have the multiplexing. So what is multiplexing and why I want multiplexing? I hope you all are familiar with mux and demux. So here, what is mux? See, multiplexing is responsible for accepting n number of input. And it converts n number of input into one output. So what is multiplexing? It's a device used to combine the input, and make that input into one output. So multiplexing is a technique used to combine and send multiple data streams over a single medium. So dear student, think that I have only one cable, but I have n number of input. So what I'm going to do? I'm going to use multiplexer to combine this input and form one single data and send that through the single transmission line. The process of combining the data stream is known as multiplexing. It's a device. It's a process of combining n number of input is known as multiplexing. It's a hardware used for multiplexing is known as multiplexer. So what is multiplexing? It's the process of combining input. And what is the hardware we are going to use? That is multiplexer. Multiplexing can be achieved using the device called multiplexer or mux. Mux is responsible for combining n input lines to one single output line. So here see, I have n number of input. Okay, after multiplexing, I'm going to get one output. So how many output? Only one output. Now, at the receiver side, I'm going to have the device called demultiplexer. It's a hardware device. It's a hardware. Demux is a hardware used to extract n number of output. See, for the demux, one input. How many input channel? One input channel. And how many output? N number of output. So at the sender side, I'm going to use multiplexer. But at the receiver side, I'm going to use demultiplexer. So demultiplexing is achieved by using a device called demultiplexer. So demultiplexer separates a signal into component signals. So here demultiplexer is going to receive only one input signal, and by applying demultiplex, it is responsible for extracting n number of output. So composite signal. So one input, n output. Therefore, we can say that demultiplexing is one to many. So one input, many output. But if I consider multiplexer, many input and one output. So it is many to one, and here it is one to many. If I consider multiplexing, I have three different types of multiplexing. One is frequency division multiplexing, then another one is wavelength division multiplexing, and another one is time division multiplexing. And if I consider time division multiplexing, this is further classified into synchronous and asynchronous time division multiplexing. Anyway, dear student, let's study the types of multiplexing one by one. So at the beginning, I'm going to have the frequency division multiplexing. It's an analog technique. Just remember, it's an analog technique. It's an analog technique. Okay. So here, frequency division multiplexing is a technique in which the available bandwidth of single transmission media is subdivided into several channels. So here I'm going to have one single transmission media. See, this is my transmission media. Okay, now whatever the frequency I have, I'm going to divide this frequency. So I'm going to divide this frequency. For example, I'm going to divide the entire frequency into 3 channels. So channel 1 or frequency 1, frequency 2 and frequency 3. And for the different devices, I'm going to assign the frequency. So for the different devices, I'm going to assign the frequency. Now, consider the example here. I'm going to have the single transmission media, and what is the frequency range? That is 1 to 19. Okay, whatever the frequency I have, I'm going to divide that frequency for individual device. For device 1, I'm going to allocate 1 to 5. For the device 2, I'm going to allocate 7 to 12. And for the device 3, I'm going to allocate 14 to 19. So I'm going to divide the entire frequency, and that is known as subdivision of the channel. The main aim of the FDM is to subdivide the available bandwidth into a different frequency channels and allocate them to a different device. So I'm going to divide the entire frequency into sub-channel, and I'm going to allocate sub-channel to the devices. It is mainly used in radio broadcast and TV network. So where we can able to find frequency division multiplexing, that is FDM, that is in our radio broadcast and TV network. What are the application here? See, TV network, whatever the channel or whatever the signal we are going to get from the FDM, that is TV network. And it's also used by the FM and AM broadcast. So FM, that is radio station, has different frequency. See, if I consider radio station, I'm going to have different frequency number. Okay, that comes under FDM. The multiplexed signal is transmitted in the air. So whatever the multiplexed signal I'm going to have, that is transmitted via the free space or air. Now I'm going to have the wavelength division multiplexing, that is WDM. It is same as frequency division multiplexing. Okay, instead of frequency, I'm going to have the optical signals. Instead of frequency, I'm going to have the optical signals. And where we are going to get the optical signals? In our fiber optical cable. In our fiber optical cable, I'm going to get optical signals. So here, fiber optical cables are responsible for transmitting the data in the form of light. So here, WDM is used on fiber optics to increase the capacity of single fiber. So here I'm going to use WDM, okay, in order to increase the capacity of single channel. It utilizes the high data rate capability, and it is also an analog multiplexing technique, and all the optical signals from different sources are combined. So dear student, here we are going to use prism. Now prism is responsible for accepting n number of input, convert that into single output. Now dear student, at the receiving end I'm going to use demultiplexer. So sender side I'm going to use multiplexer, and at the receiver side I'm going to use demultiplexer. So at the sender side I'm going to have the prism that is responsible for accepting n number of input, and I'm going to get one output. But at the receiver side I'm going to get one input and I'm going to extract n number of output. So that is known as demultiplexing. To perform multiplexing and demultiplexing I'm going to use prism. Prism can perform a role of multiplexer by combining the various optical signals to form a composite signal, and at the end I'm going to have the demultiplexer. The composite signal is transmitted through a fiber optical channel. So at the receiver side I'm going to have the demultiplexer in order to extract the signals, but at the sender side I'm going to have the multiplexer to combine the signal. So prism is also responsible for performing a reverse operation. So at the sender side as well as the receiver side I'm going to use prism. So it's going to act like a multiplexer as well as demultiplexer. And the last type of multiplexing here is time division multiplexing. So dear student, if I consider frequency division multiplexing, I'm going to divide the frequency. But here I'm going to divide the time. So frequency remains same, but I'm going to divide the time. So here it's a digital technique. If I consider frequency division multiplexing as well as wavelength division multiplexing, both are analog technique. But here I'm going to have digital technique. So in time division multiplexing, the total available time is divided. If I consider F frequency division multiplexing, the total available bandwidth is divided. The available frequency is divided. But here what I'm going to do, I'm going to divide the total time. I'm going to divide the available total time in the channel as distributed among different users. Okay, so whatever the frequency remains same. But what I'm going to divide here, I'm going to divide the time. Therefore, each user is allocated with different time intervals is known as time slot. See here, this is my channel. Okay, this is my communication channel. Okay, I'm going to have the same frequency, but for each user, I'm going to provide different time slot, and that is known as time division multiplexing. For each user, I'm going to give different time slot. A user takes control of the channel for a fixed amount of time. For example, think that I have 10 minutes. I have 10 minutes and I have 5 devices. So what I'm going to do, I'm going to give the time slot for each and every device. For each device, I'm going to give 2 minutes time. Okay. Now, in that 2 minute time, each device is responsible for using the channel. Okay. For example, if device 1 is going to use this channel capacity only for 2 minutes. After that, device 2. Then device 3, device 4, device 5. So here frequency remains same, but time slot is varies. But if I consider frequency division multiplexing, time remains same, but frequency varies. In the sense what? I'm going to divide the frequency, but here I'm going to divide the time. Now, in time division multiplexing technique, data is not transferred simultaneously. So, if I consider time division multiplexing, I'm not going to transfer the data simultaneously or continuously. And how I'm going to transfer the data? I'm going to transfer the data one after another. So, one by one. So, I'm going to send first message. After that, I'm going to send second message and so on. So, here the data are transmitted one by one. In TDM, the signal is transmitted in the form of frames. So, it is a digital technique. So, in TDM, whatever the data I have, that is treated as frame. So, that is frame. So, frame contains a cycle of time slot. For each frame, I am going to get the time. So, that is known as time slot, in which each frame contains one or more slots dedicated to each user. For each user, I am going to get the time slot. In that time slot only, they are eligible to transfer the data. It can be used to multiplex both digital as well as analog signals and mainly used to multiplex digital signal. So, dear student, in my time division multiplexing, I can have digital as well as analog signals. But mainly I am going to concentrate only about digital signals. And if I consider time division multiplexing, there are two types of time division multiplexing, that is synchronous and asynchronous. Anyway, dear student, in my today's session, I started with water switching. Along with that, I have explained message switching. Then I have covered multiplexing. Along with that, I have discussed three types of multiplexing, that is time division multiplexing, frequency division multiplexing, as well as wave division multiplexing. Anyway, dear student, let's meet in the next session with the new unit called data link layer. Until that, keep watching and keep learning. Thank you.